Hi, everyone. Thank you so much for joining our joint webinar with Komodor. We're going to be speaking today about how to control your Kubernetes health and costs. We hope you do find it very interesting and informative. We will be holding a Q&A session at the end, so please feel free to submit any questions you have to the Q&A button at the bottom of your screens. Today, we're hosting Nir Shtein from Komodor, a Kubernetes native change intelligence platform. Nir is a software engineer at Komodor and the main developer behind its open source project ValidKube. He got his Kubernetes chops at a young age while working on projects with distributed technologies, hyper-fast development life cycles, and diverse frameworks. We will also be hearing from Jeff Haines, our very own director of marketing here at Anodot. Jeff is part of the go-to-market team at Anodot, focused on helping DevOps and FinOps teams maximize the value that they get out of the investments in cloud and Kubernetes. He spent the last 15 years in various development, creative, and marketing roles, and has been working with cloud solutions since 2013. So we really hope you enjoy the webinar, and over to you now, Nir.
Thank you very much, Noah. So let me share my screen. So let me tell you more details about myself. So as Noah said, my name is Nir, and I'm a software engineer at Komodor. And in the end of this session, I will show a short demo on the Komodor platform, and I will talk more in details about Komodor. And also, as Noah said, I'm the main contributor of ValidKube. A little bit about ValidKube. ValidKube is an open source project that aggregates other 5 open source tools that let you validate, clean, secure, and run audit checks on your Kubernetes YAML files. Welcome to visit invitecube.com and, of course, to contribute. More than that, open source advocate and general huge Kubernetes fan. So without further ado, let's start. So the first thing that I want to talk about are the challenges that Kubernetes present nowadays. And there are many challenges and many difficulties that we can see in the areas of Kubernetes. The first challenge that I want to talk about are the blind spots around the Kubernetes clusters. So the keyword here is automation. Kubernetes is doing a lot of automation behind the scenes without the users know about this information. And what I mean by automation, I will give very common and very simple example of automation that Kubernetes does behind the scenes. And this is rollout, let's say deployment rollout. So what actually happens when you want to kubectl apply on some deployment and do a rollout? Kubernetes starts and create new replica set. The new replica set create new pods, and the pods get initialized and start. And then Kubernetes transfer all the traffic from the old pods to the new pods. And then after FN went successfully, he deleted the old pods and then delete the old replica set. And there is it, the rollout completed. This might be a very simple process, but it can also go wrong. Like if one of the pods didn't get terminated, or one of the new pods didn't get successfully. So what are we doing now? How can you troubleshoot it? How can you solve it? It can be very difficult and very frustrated how to solve it. And this is only one example of things that can go wrong. There are many other blind spots and many other places that Kubernetes is doing behind the scenes that we doesn't aware of them. And this is generally lead me to my second point. And this is that many of the Kubernetes users start to use Kubernetes, and in first glance, it's very easy to use the platform. And because you need only to use kubectl, and there is it, you have a resource running on your Kubernetes cluster. But as you get deeper and deeper inside the platform, you get to know that you have many more things to know about the platform, and you have really gap in your knowledge in Kubernetes. I know that in many organizations, there's like a small group or even one person that are really expertise and know enough to run Kubernetes in their production environments. The third and last challenges that I want to present is that, let's say Kubernetes is very dynamic. It have many moving parts and everything is changing. Pods are ephemeral thing. They get created and died all the time. And it's very hard to track all the changes and all the events around the cluster. And let's say you doesn't have only one cluster, you have so many clusters. So it even gets the process much more harder and difficult. Like the common word that I continuously repeated that is complexity. Kubernetes is complex and we have many capabilities, and there are so many things to know about this huge platform. I like to do some simple comparison between driving a car and using Kubernetes. I think they're both very similar processes. When you start driving a car, it's very simple. You go into the car, you step the gas, you step the brakes, you move the wheel from right to left. But let's say after a few minutes, your engine starts to smoke. By that point, you stop your car and look under the hood. All you can see is smoke and your engine. And you'll probably call your mechanic and tell them to pick your car to the garage. And they will fix the problem for you. And as compared to running Kubernetes, in the start, it's very easy. You have some image, you put it on some deployment, you want simple kubectl command, and there is it. You have a container that is up and running. You can also attach some service or some ingress, and then you can access your service outside from the cluster. But let's say after a few days, you get the most annoying error in Kubernetes, and this is crash loop backoff. Generally saying that your application is continuously crashing, very annoying. So how you tackle it? In this scenario, you are the mechanic and you need to fix the problem. So it's very problematic. In this slide, I attached some meme from Reddit that generally describes all the terms and all the related terms of Kubernetes divided by sublevels. And as the metaphor of the iceberg go, only when you go deeper and closer, you get to realize that you have much more things to learn and much more things to know. And this metaphor is perfect for Kubernetes. As I said before, when you start to use Kubernetes, it's very easy. It's enough to know what are the simple resources. It's enough to use only kubectl. But when you want to do advanced thing and use the really capabilities of Kubernetes, you need to know all the ecosystem. You need to use advanced capabilities of the platform. You need to do a lot of things that you aren't aware of them. So in the last 4 minutes, I talked many times how Kubernetes is complex and how much is hard. So the upcoming question is, how can we simplify the Kubernetes troubleshooting? How can we simplify generally the Kubernetes world? So I will show you 4 best practices that I can recommend how as Kubernetes users we can do it. So the first best practice is to maintain good YAML hygiene. Keep your YAML very small and neat. And why is that? YAMLs in Kubernetes are like the desired state. Kubernetes is strive to be like the content that is written inside the YAML. So how can we improve our YAML files? The first thing is to include important metadata inside the YAMLs. 2 common metadata are labels and annotations. Many people get confused between those terms, but they are very simple. Labels generally are meant for you. They are meant for the Kubernetes users. They're meant to you to like divide your resources into groups or into subgroups. And on the other hand, annotation like the opposite. They're not for you. They are for third-party tools or for some libraries. So if you doesn't need any annotation, just don't put it. The second very common mistake that I saw, that people put their raw configuration directly inside their YAML file. And what you really should do is put your configuration in config map, the secure configuration in secrets, and then just reference your environment variables to the config maps and to the secrets. And the last thing that I want to include in my YAML file that is related to workloads are the liveness and readiness props. Liveness and readiness props are great things, and I won't talk a lot about them. But generally, readiness props are there to determine if your container is ready to accept traffic, and readiness props are there to determine if your container needs to be restarted. So the second thing that I want to recommend on is to do specific logging that is related for Kubernetes. As Kubernetes user or any platform, we put logs inside our applications. So what's special when I log inside Kubernetes? So first of all, many people many times log the pod name. It is nice, but it's not so much helpful. What is really helpful and what we really care about is the service name. And because the service name isn't ephemeral, it doesn't change. It's concise all the time. And by that, you can track your service and what happened to it. More than the service name, I also want to track the version. As an example, of version 1, 2, 3, and 4, I had a bug, but in version 5, this bug seems not to be occurred. So I can know that in version 5, my problem got resolved. More than that, many times my application isn't the only guilty when things go wrong. Many times it could be things that relate to my cluster. Let's say a node issue, network issue, storage issue, many other things. The third best practice that I want to recommend on is separate your environments. I'm sure that everyone that uses Kubernetes or not using Kubernetes is separating their environments. But if you're a Kubernetes user, you have like two main best practices how to do it. The first one is to separate your environments via clusters, and the second one is separate your environments via namespaces. When you separate your environment via cluster, it means that you have separate cluster for each environment. By doing so, you have really high insurance that you doesn't have any dependencies between your clusters. If you do some post-cluster changes in your staging cluster, it won't affect your production cluster, and vice versa. But the drawbacks of this method is that you need to invest much more effort in your infrastructure, and you need to invest much more effort in maintaining like upgrading and other things that you need to do if you have many clusters. And as I said, the second method is to separate your environment via namespace. Means that you have different namespaces for each environment on one or two clusters. The main benefit of this method that you doesn't need to invest so much effort in your infrastructure and in your maintenance. And the really drawback in this method is that you now do have dependencies between your environment. If you do some hard change in your staging environment, it will affect your other environments. And the fourth and last best practice that I want to touch on is monitoring. Really invest in your monitoring. I'm sure that also, as every Kubernetes or every platform user, we monitor our environments. So the first thing is to choose your monitoring tool. You can choose some open source monitoring solution like Prometheus or Grafana, and you can choose some commercial monitoring solution like Datadog or New Relic. And when you have open source solution, first it's free, it's nice, but it will take you much more time to set up those environments. And on the other end, commercial solution cost you money, but they're much more easy to set up and to configure. So now that we choose how we want to monitor our cluster, let's see what we really want to monitor in the clusters. So the first thing is the resources usage, meaning CPU, memory, storage. By knowing these metrics, I can ensure that my metrics doesn't have some memory leak or get out of memory, that my pods aren't throttled in their CPU. The second thing that I want to monitor is the status of my containers, of my nodes, of my pods. By knowing what is the status of my pods, I can see what is happening right now. Is my services available or unavailable? Is some service is very flaky and restart all the time? And the third and last thing that I want to monitor, and this is for my business, it is my application performance metrics, aka APM. And this is for me, it's for my business, and it is important for every business. So after I talked a little bit how as Kubernetes users, we can reduce the complexity of Kubernetes, I want to talk more in details how Komodor reduce the complexity and how Komodor illuminate the Kubernetes darkness and shine the light on some Kubernetes blind spots. So before I show a short demo, I want to talk a little bit about Komodor. So as I say, Komodor is a SaaS platform that helps you to troubleshoot incidents and problems of the Kubernetes. And the goal of Komodor is to help dev and ops and DevOps teams to solve problems in efficient way and in a very minimal time. And like as a simple Kubernetes user, in order to tackle or solve problem, I need to run a variety of kubectl commands. I need to look all over my monitoring tools. I need to look on GitHub on my CI/CD pipelines. But Komodor does all of that for me. Komodor collects all the events and all the changes around my clusters, around my monitoring tools, around GitLab, my CI/CD pipelines, and then process and ingest all those changes into one platform, into Komodor. So when I have a problem, I go to Komodor, and this is the one place that I need to go to. I have all the context and I have like a full image of the problem. So now I can solve the issue very fast in a very short time. So by that, I reduce the time it takes me to troubleshoot problems. And now I spend more time in the thing that we all love, and this is, of course, the program. Before I show the demo, I want to pinpoint the thing that Komodor really shine a light on. And those are multi-cluster visibility. As a kubectl user, I have only context to one cluster each time, and this is not the case in Komodor. And the second thing is that Kubernetes is stateless. It doesn't remember what happened yesterday. It doesn't remember what happened a week ago, and not what happened a month ago. And I will show how Komodor can draw a timeline all over my events. And the third thing that I want to show how Komodor shine a light on is node issue. As a kubectl user, I can troubleshoot node issue, but it's very complex and very pain process. And I will show how Komodor simplify this process and make it very easy. So without further ado, this is the Komodor platform. Wait a second. Yeah. So this is generally the main view that show me all the services, meaning my workloads, deployments, daemon set, set, across all of my clusters. So in this platform, I have like 4 clusters: Algo, Demo, GKE. And let's say I want to filter to some specific cluster. Let's say Algo. Now I can see all the services that currently running only on this cluster. So let's take some real-life example. My customer called me yesterday and told me that he had a problem with the transaction API service. So now I can filter to my transaction API service and also deep dive into the service. So now I can see details about the service, some metadata like what is the image, what is the namespace, number of replica sets, and so far. I can also see in the main view what happened to the service. I can also see what happened and not in 24 hours, like what happened also in the last week. So as you can see, in the last week, I had several rollouts that are represented by a green line of deploy. And I can see that almost after every deploy, I had also availability issue, means my service was unhealthy. So my customer didn't complain for nothing. I really had a problem. So now I want to investigate what is the problem and what is the root cause. So maybe I will try to see events that related to my pods. So I will attach some pod and see the event that related to pod. I don't have any special information about the pod, but I can see that after every time I had availability issue, right after that, I have also a node issue. So maybe they are correlated to each other. I will click on the node issue and open the playbook. And this is generally what Komodor did for me. Komodor ran like, I think there were 8 checks here that Komodor checked for me. So like as a Kubernetes user, I need to run all of those checks. Let's say that I remember and know all of those checks. It will take me a lot of time to do them. So now that I concluded that the problem is related to the node, let's see why the node got unhealthy. So I see like 3 red flags here, and one of the flags really shine up, and this is that my memory was overcommitted. So I will click on that, and I can see what Komodor checked for me. So they told me that kubectl describe node, so that my memory is overcommitted, and they also told me how to solve the problem. Tell me maybe you need to add more nodes, maybe you need to replace the node with more memory. And this is the solution for my problem. So now I close the loop. I had a problem, I verify the problem. I see that the problem is related to problem with my node. And I see the problem of my node, and now I can see the solution for my problem. And so this is what the demo. So without further ado, let me pass the mic for my friend Jeff. Well.
All right, awesome. So that was great. I think everybody can see my screen, hopefully. So I'm going to dig in specifically to Kubernetes costs and Kubernetes cost blind spots. I'll describe each of them and discuss strategies for managing them. And then I'll also talk about how Anodot can deliver complete FinOps and cloud and Kubernetes cost management. So according to the Cloud Native Computing Foundation, CNCF, 96% of organizations are already using or evaluating Kubernetes in 2022. Kubernetes has crossed the adoption chasm to become a mainstream global technology. But it isn't all sunny skies. You just heard from Nir about the very real impact of technical Kubernetes blind spots. When the health of one of your services in Kubernetes is suboptimal and you can't troubleshoot it efficiently or effectively, dollars are at risk for your organization. There's also tremendous potential cost impact for your organization due to lack of visibility into the cost of operating Kubernetes in the cloud. Again, according to CNCF, inefficient or non-existent Kubernetes cost monitoring is causing overspend for many businesses. Without a focus on cost visibility and management for Kubernetes, waste is permitted. And the primary challenges are collaboration and responsibility, made so difficult by all the complexity that Kubernetes is introducing to organizations. And we just went through all this complexity with Nir, so I think it's very apparent to everyone, if it wasn't already. So engineers and architects historically did not have to worry too much about operational costs, but now they're on the hook for the financial impact of their code's resource utilization, their node selections, and pod and container configurations. Meanwhile, finance has had a hard enough time transitioning from the CapEx world of on-premises IT to OpEx-driven cloud and comprehending cloud cost drivers and the complexity of the cloud bill. So we can't expect finance to become Kubernetes experts in order to become sufficiently able with Kubernetes cost management. That's why organizations have cross-functional Kubernetes value realization teams. Some call it cloud FinOps, some call it a cloud cost center of excellence or cloud center of excellence. Some call it, in some organizations, just a simple partnering of DevOps and finance. The goal of this team is to strategically bring engineering and finance together and remove barriers to maximizing the revenue return on your business's investment in Kubernetes. So at first, this probably sounds like an operational tax on engineering, but when it's done right, it's about helping engineering make informed cost impacting decisions and to justify those decisions to the business to show that dollars spent on Kubernetes are driving top line revenue. So in an ideal implementation of this, all stakeholders are taking some responsibility for visibility, optimization, and ongoing monitoring of costs. DevOps and engineering take responsibility for understanding and monitoring the cost impact of their decisions. Finance agrees to partner with engineering in ways that do not reduce agility and don't add too much operational overhead. And finance becomes partially literate on Kubernetes concepts and cost drivers so they can contribute meaningfully to cost management efforts. So where should your organization start? Right now, getting control of Kubernetes costs depends primarily on getting better visibility. Again, CNCF lumps all aspects of visibility together with monitoring, but when asked what level of Kubernetes monitoring organizations have in place, nearly 45% of respondents were simply estimating their costs, and nearly 25% had no cost monitoring in place whatsoever. So we know that 75% of organizations are running Kubernetes workloads in production today. So now is the time to eliminate Kubernetes cost blind spots by understanding the Kubernetes cost drivers and how to get visibility into them. So let's understand what aspects of Kubernetes are driving costs so we can begin to better build organizational visibility. There's 7 primary Kubernetes cost drivers, your underlying nodes, the cost impact of how you configure CPU and memory requests and limits for each pod, mismatch between ephemeral pods and persistent storage volumes, the impact of the Kubernetes scheduler, data transfer costs, networking costs, and costs incurred to how you architect your applications. We'll briefly dive into each of these and explain how each one contributes to your overall Kubernetes costs. And then I'll outline key criteria for driving organizational visibility into each and optimizing each. So the first cost driver is also the largest driver of costs usually. It's the cost of your underlying nodes. Nodes are your VM instances, and you pay for compute capacity of the node that you've purchased, whether your pods and their containers fully utilize it or not. Parameters that impact a node's price include the OS, the processor vendor, processor architecture, the instance generation, CPU and memory capacity and ratio, and the pricing model that you choose. You have all the considerations of choosing a regular cloud instance in EC2 and a lot more. Maximizing utilization without negatively impacting the workload performance can be very challenging. And as a result, most organizations find that they're heavily over-provisioned with generally low utilization across Kubernetes. Your pods aren't a billable component, but their configurations and resource specifications drive the number of nodes that are provisioned. Visibility into the cost impacts of your pods is absolutely critical. We find that CPU and memory are often over-provisioned for each pod, and this means you're likely buying node resources you don't actually need. When requests are too high, nodes can be added to your cluster without the existing nodes being fully utilized. We also see many cases where requests and limits for CPU or memory are not set at all. If you set a CPU limit, but not the request value, your pod will be automatically assigned the request value that matches the limit, and that can result in more resources being reserved than necessarily required. And then aside from the cost impact, there's a real risk of performance issues ranging from over-provisioned pods hogging too many resources, or even the kernel out of memory killer process terminating pods. So it's important to set these and get them right. 3, Kubernetes supports many types of volumes, which are the directories containing on-disk files that are accessible to the containers within a pod. Volumes are a mechanism to connect ephemeral containers with persistent external data stores. Volumes are a billable component, so each volume attached to a pod has costs driven by the size and the type of the storage that you've attached. You're billed for storage volumes whether or not they're fully utilized. And unlike ephemeral volumes, which are destroyed when a pod ceases to exist, persistent volumes are not affected by the shutdown of pods. So deleting an application that's using a persistent volume might not automatically delete its storage. The Kubernetes scheduler. The scheduler is the authority for where pods are placed, and as a result, it has a large impact on the number of nodes in your cluster. The scheduler first filters through the available nodes to compile a node list of those on which the pod can feasibly be scheduled. Then it scores the node in the list and assigns the pod to the node with the highest ranking. Suboptimal scheduling can cause nodes to be underutilized, and it could cause additional unnecessarily nodes to be added to your cluster. There's a number of ways you can influence node availability to the scheduler, primarily through use of labeling and controlling things like the maximum number of pods per node, which pods can be placed on nodes within a specific AZ, which pods can be placed on a particular instance type, and which types of pods can be placed together. Your Kubernetes clusters are deployed across AZ's availability zones and regions to strengthen resiliency. However, data transfer costs are incurred anytime pods deployed across AZs communicate in the following ways. When they communicate with each other across AZs, when pods communicate with control plane, when pods communicate with load balancers, in addition to regular load balancer charges, when pods communicate with external services like your databases, that might be external, and when data is replicated across regions to support disaster recovery. 6, networking. When running cloud on infrastructure, the number of IP addresses that can be attached to an instance or VM is driven by the size of that instance that you've chosen. In cases where you need more IPs than a particular instance size offers, you may have to upsize to an instance size with a large enough IP address offering. Scaling from a large to an X large instance to gain additional IPs could cost you double, and the node's additional CPU and memory resources would likely go underutilized. Application development choices also have a major impact on your realized Kubernetes costs. It's difficult to thoroughly model these and tune the resource usage of applications. And developers might focus more on resource allocation within Kubernetes and pay less attention to optimizations that can take place at the code level and app level to improve performance and resource realization and reduce resource requirements during development cycles. And finally, the big 3 cloud service providers also charge you per cluster. For example, in AWS, you're charged $73 per month per cluster in EKS. So architecting everything appropriately has cost impacts. So How do we get visibility into and optimize each of those 7 Kubernetes cost drivers? So first, you'll want complete visibility across all your nodes into instance details and to business mappings that tie nodes to relevant business objects like your services, apps, teams, or business units. Your primary task with optimizing your nodes is to choose nodes that best fit your pod's needs. This includes picking nodes with the right amount of CPU and memory resources and a ratio of the two. When possible, use open source OSs on your nodes to avoid costly licenses and license management efforts. If you choose like a Windows OS, you're gonna have to pay for that. Select your processor carefully. All 3 of the big cloud providers enable you to select your processor vendor, and each has meaningful cost impacts. In AWS, you'll usually find that AWS ARM-based Graviton instances are more powerful and cost-effective than alternatives from AMD and Intel. Take advantage of commitment-based pricing, which delivers some impactful discounts. Master and leverage scaling rules using a combination of horizontal pod autoscaling, vertical pod autoscaling, and the cluster autoscaler. And scaling rules can also be set per metric, and you should regularly fine-tune these rules to ensure they fit your application's real-life scaling needs and patterns. You need visibility into the requests and limits for CPU and memory for each of your pods, and the delta between what you've configured and what you're actually using. You want to have organizational policies in place for setting pod CPU and memory requests and limits in your YAML definition files. Once your containers are running, you gain visibility into the utilization and costs of each portion of your clusters, names, spaces, labels, nodes, and pods. And that's the time to tune your resource requests limit values based on actual utilization metrics. Kubernetes allows you to fine-tune resource requests with a granularity up to the MIB and RAM and a fraction of a CPU. So there's no hard upper barrier to maximizing utilization through continuous optimization. We recommend configuring and using the vertical pod autoscaler as well to automatically tune requested limits. Optimizing your volume costs. So you need visibility into unattached persistent storage. Persistent storage volumes have an independent life cycle from your pods, and they'll remain running even if the pods and containers they're attached to cease to exist. Even deleting an application that uses persistent volumes might not automatically also delete its storage. So in many cases, you'll have to manually delete the persistent volume claim resources to clean up. Set a mechanism to identify unattached EBS volumes and delete them after a specific period has elapsed, and size your volumes carefully when you're setting up your clusters. You pay for provisioned storage whether or not you use it. Optimizing scheduler-driven Kubernetes costs. So you want to get visibility into and monitor pod and node utilization so you can determine whether and where you can optimize costs by tuning kube scheduler configurations and preferences. Use scheduler rules wisely to achieve high utilization of node resources and avoid node under provisioning. As described earlier, these rules impact how pods are deployed. Make sure your pod resources and requests and limits are set so the scheduler is not left to its own devices to interpret the limits. Node capacity can quickly become exhausted by the scheduling of undersized pods, causing a trickle-up effect where the cluster autoscaler may add additional unneeded nodes to your Kubernetes deployment. In cases such as where affinity rules are set or pod resources are not set, the number of nodes may scale up quickly, so monitoring and anomaly detection are also necessary. Optimizing your data transfer costs. First, you'll need visibility into your existing Kubernetes deployment of what pods are incurring data transfer charges and the ability to categorize them by business objects like teams, services, apps. Consider designing your network topology so that it will account for the communication needs of pods across AZs so you can avoid added data transfer fees. Data transfer charges may also happen when pods communicate across AZs with each other, with the control plane, load balancers, and with other services. So another approach for minimizing data transfer costs is to deploy namespaces per availability zone, 1 per AZ, to get a set of single AZ namespace deployments. And with such an architecture, pod communication remains within each availability zone, preventing data transfer costs while allowing you to maintain application resiliency with cross-AZ high availability setup. Optimizing network costs, you'll want continuous visibility into IP and resource consumption for each of your nodes. And when architecting your cluster, plan node usage and leverage the kube scheduler and cluster autoscaler capabilities to avoid paying for larger nodes with the resources you won't actually use. Optimizing your application architecture to reduce costs is highly specific to each application you have. At a high level, you'll want complete visibility into your clusters to account for all Kubernetes elements and resource utilization. You want to monitoring resource utilization, which will let you look for macro opportunities to reduce that resource utilization in your code by looking at whether or not a container is using more resources than you expected. Examples of some application level optimizations include choosing between single and multi-threading, leveraging a more cost-effective operating system, and taking advantage of multiprocessor architectures like x86 and ARM64. And finally, minimize your cluster counts when you can. So how can you enable FinOps that covers all of this for Kubernetes? Anodot gives you continuous visibility into your Kubernetes costs and their drivers, everything we've just discussed. So you can deeply understand what elements of Kubernetes are contributing to your costs and tie them to business objects like services, apps, and teams. Everything you need to justify, monitor, and forecast Kubernetes related spend and help foster collaboration between FinOps and DevOps. With Anodot, you can visualize your entire Kubernetes and multi-cloud infrastructures from macro infrastructure-wide views all the way down to specifics of each container. You can empower your FinOps team to allocate and track every dollar of spend to business objects and owners and reveal where costs are originating. And you'll get finance and DevOps teams on the same page with appropriate personalized reports and visibility. Next, we help you optimize and reduce cloud waste with savings recommendations your DevOps teams can actually implement via CLI or console. You'll be able to purchase the right instances in most cost-effective ways, and you'll utilize them fully. And we currently have over 40 types of multi-cloud waste reduction recommendations and cost savings recommendations specifically for Kubernetes are in development right now. Finally, we help you monitor your cloud spend so you can respond to anomalous activity immediately and are never surprised by your cloud bill. We have a team of data scientists that have delivered machine learning powered forecasting that helps you accurately predict costs and negotiate enterprise discounts. And with Anodot, you'll realize a culture of FinOps that tackles and solves the Kubernetes cost visibility problem. So just specific value for Kubernetes, we deliver the deepest visibility, allocation, and attribution of Kubernetes costs from the cluster down to the pod, continuous Kubernetes cost monitoring, and coming soon, highly relevant, easy to implement cost-saving recommendations for Kubernetes. And don't take our word for it. Leading enterprises choose Anodot because of our Kubernetes abilities. And in many cases, they're dropping legacy FinOps tools because we've shown and deliver much greater value. We'd love to share some of the stories about this with you. So please reach out to us and start reducing your Kubernetes waste. So thank you. Now we're going to open up the floor for questions. If you have one, please type it into the chat box. And Noah, I believe you're going to administer the questions for us.
Sure will. Thank you so much, Jeff and Nir. That was very, very interesting. We have a couple questions coming through. First one's for Nir, actually. Nir, can you actually perform actions on Komodor, or do you still have to switch to K9s or something similar?
Yeah, so this is like recently capabilities that we added to the platform Komodor. Now you can do currently now you can do simple actions, but later on you can do some advanced actions. Now you can scale your replica set. You can restart your deployment or other service. You can compare between some services, and you can edit some resource, and you can also delete one of the ports, replica sets, whatever that you want.
Awesome, thank you. This next one is for Jeff. Jeff, when will Anodot have saving recommendations for Kubernetes?
So that's something we're working very hard on. We're going to have cost saving recommendations, I believe, within the next couple months. We're working very hard on them as a team, and we're excited to deliver them. I believe the first few are focused directly on maximizing utilization, which, we saw that, utilizing your nodes and getting those costs down is the primary driver of waste. So we want to absolutely enable the industry to be able to do that.
Awesome. And Nir, what K8 resources can Komodor cover?
So Komodor generally can cover all the resources, all the most common resources that exist in Kubernetes, all the storage, network, workloads, common resources, and can do a simple table like you will done with simply kubectl get command. And this is it.
Great, thank you. I guess this next question is kind of for both of you guys, but what's the main difference between what Komodor and Anodot offer? So if Jeff, you want to take that first, and then maybe Nir can expand on that.
Okay, so Anodot's specifically focused on cost. Hopefully that came through in the presentation. We're going to look at enabling FinOps and cloud cost management. That's all we do. There's other tools sort of in the same space as us that do a lot more management and automation. But really what you're going to look for those capabilities is over to Komodor. So I'll let Nir answer how he believes we're different.
Yeah, so it's very simple. Komodor and Anodot can come together. Generally, the purpose of Komodor is to help troubleshoot problems and incidents. This is it. And the purpose of Anodot is to help your cost optimization. And you can choose both Komodor and Anodot together, and they are a great result.
And I believe we do have customers that are using both products. So that's definitely tried and tested and true. So.
Great. So that's actually all for our questions. A great one to end on. So we really hope that you enjoyed the webinar. Thanks so much to everyone who joined. The webinar recording will be sent to you via email, so no worries. You'll be able to go back and see anything that you'd like. And we at Anodot definitely have a lot more cloud cost related webinars coming soon, so stay tuned. And I'm sure Komodor will as well, so follow us on social media and stay tuned to our emails coming through so you can join more awesome webinars like this one. I want to thank Jeff and Nir again for sharing all their knowledge with us, and I hope you all found it very enjoyable. Thanks again. Have a great rest of your day.
Awesome. Thank you.
And thank you everyone for joining.